Good day. I hope you are all doing well. It's a joy once again to come to you with another video which is purposely for helping you to understand exploratory factor analysis using the SPSS. So in this video, what I'm going to do is that I'll take you through data entry into the SPSS software, reliability test of data, mean scoring, normality test of your data set. After the normality test, are you going to use Kruskal-Wallis test or Mann-Whitney U test or what? Or is it ANOVA or independent T test? We'll get to know all these things. Then we go into the actual exploratory, the EFA, the exploratory factor analysis. But before we run the exploratory factor analysis, we will look at some basic conditions that we have to meet before we can make our work good. So KMO, Bartlett's sphericity test, commonalities, eigenvalues, factor loadings, rotation, principal components, etc. All these things, I will explain them to you. Then finally, I'll go ahead and interpret the results that we'll get. But before that, I want to issue a disclaimer as I did it in the other video, in the last video. The materials used in this tutorial video are for only educational purposes with no intention of making profit or gaining financial advantage. The materials have been cited, from online. I mean, most of them are, I would say almost all of them are online documents, have been cited or used fairly for illustration and explanation to students. So I want to issue this disclaimer before we start. Okay, so I'll go straight to the point so that we can work this thing out very fast and finish it. Don't forget, I took you through this last time, but the reason why I decided to come back to this thing again is that I mentioned that some of the things, for the sake of introducing this topic to you, I couldn't get that opportunity to explain so many things. I was just running through it to finish it. I didn't really get time to explain so many things to you. So today, my aim is to just take them one by one, step by step, so that even if you have not done this thing before, when you get opportunity to do this, you can do this on your own. Okay, before we go into the data entry, I would like to mention once again that we are building up to work on what we call fuzzy synthetic evaluation. And in the process of building up, you need to conduct your exploratory factor analysis. The question that somebody will ask is it always that you have to conduct exploratory factor analysis? It's up to you. There are studies I've seen where they conduct confirmatory factor analysis. And if you remember in the last video, I mentioned that we have two main types of factor analysis: confirmatory and exploratory. Well, other books, this thing will say that, okay, there are other types, but these are the two which are known in literature. So what we are doing, or all the things that we are doing now, we are building ourselves up to work on the fuzzy synthetic evaluation model. So I introduced to you in the last video that we are using two documents. One document from Dr. Ibrahim Wuni, a study that he conducted and published titled Quantitative Evaluation and Ranking of the Critical Success Factors for Modular Integrated Construction Projects. That was one of the documents. Then another document I told you to get, and please, once again, if you are going to follow me, any instruction I give to you, do your best to follow it. It's for your own good, because I normally do a thorough research. I do a lot of studies, I do a lot of reading before I come out with these videos. So anything I tell you, do your best to follow it. The second paper I recommended to you to go for is a fuzzy synthetic evaluation analysis of operational management critical success factors for public-private partnership infrastructure projects by my own professor, Robert Oseche. So do your best to get these two documents. Okay. So last video, I started with this. So I want to continue so that if in case you avoid the other video, you'll not be confused. Actually, it's almost the same thing that you see in this document. It's almost the same thing that you see in Robert's document. Okay, so to do this whole thing, which also forms the basis of a good research, is that if you want to conduct any good research, you need to conduct a very good literature review. And that's exactly what I have done with you by writing 2 literature review papers with you, which currently they are under review. One on a systematic review and one on symptometric review. Okay, and I am hopeful that you have gained a lot of experience with this. When you conduct a literature review, you'll be able to get to know. So here, he was looking at the success factors, the factors. Factor analysis is not only for factors. I mean, when I say factors, I mean success factors or determinants. Factor analysis can also be used for barriers, risk. Anything that has, I would say, that has a number of variables. Let me put it that way, because sometimes that's a little bit of misconception that factor analysis is only for factors. Anything that has a number of variables contributing to it or causing it, you can use factor analysis to analyze it. Or any phenomenon that has a number of variables, I would say, from my own experience, I would say more than 10, 15, 20, 30 variables, any phenomenon, you can use factor analysis to do that. And to get these factors, you need to conduct a very good literature review. So we have done that. So once you are done with your good literature review, and you have come up with a number of factors, as Dr. Wuni did in this article, so you can see the references where he took the factors from. Then once you are done, you can give it to an expert, or you can do it yourself, depending on your level of experience in academia. And then you finalize the list of variables. I don't want to be using the word factors. I prefer variables. So the variables that you want to put into your work. And into your work, I mean, when you are designing your data collection instrument, it can come in a form of interviews, it can come in a form of survey, but questionnaire surveys are normally recommended. They are recommended. If you want to know why, you can read more about that. Okay, so it's recommended you put your factors in there and you distribute it, just like as I've been doing this with you. So I think you have been following and you understand what I'm talking about. And then once you distribute it, definitely you get a result. So far we have the results for the data that in the survey that we distributed. So we have the questionnaire survey data. Okay, so now we have the data. Participants, experts, professionals, academics, they have responded to our survey, so we have the data. So what next? The next thing to do is that you have to do the analysis. So the analysis, at the analysis stage, you can do something that we call data cleaning. And with data cleaning, you can look at the outliers, which we're looking at the extremes. And in situations where some of even your initial analysis, you can also see that the questionnaire, they were not fully filled. So maybe out of 15 questions that you put into the questionnaire, maybe only 3 were responded by one of the respondents. You can decide to take it out. So you can do some of these cleaning. So after doing the cleaning and all that, then you get the data that you have to work on. So in working on the data, you can decide to do what we call the reliability analysis. You can test the reliability of the data. But before you test the reliability, you need to enter the data. So I'll start with the data entry with you. I have already done some, but I just want to help you out so that you understand. Okay. So with respect to your data entry, when you open your SPSS, okay, let me start with new. So let's assume you have your SPSS. Let me start with new so that you understand. Okay, so when you open your SPSS like this, you come to file, you click on file, you click on new, and you click on data or data. And you click on it, you get something like this. When you get it, you can click on at the down left-hand side, you can see data view and variable view. So click on the variable view. So in the variable view, you go here. You can start with how you structured the survey. So normally, you remember in surveys, we have the profile, the background, the basic information of the participants. Where some of them capture the gender, some of them capture the sector in which the respondent is coming from, some of them capture their profession, the number of years that they have worked in a company or on a project or something. Yeah, so you can begin with that. So for example, I'm just an example. I am looking at, which I've already done it before, I'll take you there. I'm looking at the sectors where the respondents are coming from. So if I'm looking at the sectors, I can just write sectors. Basically, you put sectors here and you click enter, you get this information. Okay, so with this information, you can decide to expand it, the label. Okay, so it depends on, and this is more of the variable. So sectors, this is variable. So is it numeric? Numeric in the sense that it may happen that the sectors that you are putting there, it will not come in the form of numeric, but it will be a string. It could be a comma, it could be a dollar, it could be a date. Okay, because it could be a currency, it could be a scientific notation, it could be a string, it could be something. So whatever it is, just put it there. Okay, if it is a date, maybe the time that they responded to the thing, because when some of the things we don't need them, because respondent A will respond to your survey on Monday, the 15th of August, 2022. Another one will respond on this date, so and so of that. Yeah, so, or a scientific notation or something. We don't need that, but here I prefer to make it numeric in a sense that I will end up turning the sectors into variables values, which I'll put them there. The weight and the decimals depends on you, how you want to categorize that. The label is here, like how you can explain it more. You can say sectors of respondent. That's where you give more explanation to that. Then the value, with respect to the value, this is where you help us to know the sectors that you are talking about. So you can use values to represent them. So you can say 0 is for the public sector. It doesn't mean that the public sector is 0. Please don't get it well. Or you can say 1, depending on whatever. I prefer using 1 rather instead of saying 0. Then the private sector, sorry, 2 for private sector. Then 3 for academia. Which I have decided to categorize this way. It doesn't mean that I'm 100% right, because most studies I've seen, They normally categorize respondents into public sector and private sector, but depending on how you want to categorize sectors. If it is gender too, depending on how you want to categorize gender, whatever you want to categorize, it depends on you. You can give them the values. You set the values, and then you click OK. Okay, then there's a measure. So normally in SPSS or all data, we have a way of measuring the data. Which other studies call them? Because the other time I mentioned to you that some of them call them scale. Some of them also call the level of data. There are different names for that. So we have ordinal, we have nominal, and then we have the scale. Now, the scale in this context represents the ratio and the interval as far as the SPSS is concerned. The ordinal, the ratio and the scale normally refers to data which tend to be more kind of, I would use the word more, come in a form of ratios, decimals, continuous data kind of. Yeah, and then we have ordinal. The ordinal tend to be discrete, but the rank. Okay, you rank 1 to 5, like a scale, 1 to 7, 1 to 9, 1 to 11. So that's the ordinal. And then the nominal tend to be like the ones that don't normally have numbers. Okay, so to get a better explanation of these measures, I saw something here which I think I can share with you, which you can read. So let's look at it. So choice of nominal, ordinal, scale data in SPSS. So nominal can be placed into categories. The categories have no numeric value. So with a nominal, we assume that they don't have numeric values. These also have no order and often displayed on a pie chart. If you appear to have categories with an order, you may have ordinal. Yeah, no, this is ordinal. Okay, then ordinal. Ordinals have an order, like hot to coldest, first to last, strong to weak, or the strongest to the weakest. If you can rank your data first, second, then you have an ordinal data. Scale. In SPSS, you use a scale variable option for variables on the interval or ratio scale. The interval has meaningful divisions like temperature. So temperature 25 point something degrees Celsius. So and so and so and so continuous. Variables on the ratio scale have meaningful divisions, but the zero has a specific meaning. Okay. Yeah, so these are the forms of measures of data in SPSS, which you can categorize. Okay, so depending on the data that you are using, you can categorize your data and you can choose to do that. And depend on you, the data that you are looking at. Okay, so let's get back to what we are doing. Yeah, so here I'll choose nominal because sectors, and under circumstances, they are not supposed to have numbers. But I decided to just assign numbers to them. Then I come to the variables. So I've already done this, so I'll take you there, similar one, so that we don't waste too much time. Okay, I did this in the other one. Okay, so here the sector, I want to add the third one, which in this case is academia. Okay, so when it comes to the variables here represent, let's say, the factors influencing sustainability in the construction industry. And I've been able to identify 12 factors. So you can see all the factors here. So all these factors, they are there. And is there any data missing? No, nothing is missing. Well, in the situation where something is missing, you need to specify if there's something missing. But as far as no missing values, none is missing. Columns, okay, that's okay. Align, these things are not important, but here you need to look at this one, which is very important. The measure. So measure, as you can see, this is a nominal measure as far as the sectors are concerned. Okay, so when it comes to labels here, I can decide to give further sectors of respondents. So what are the factors? Maybe I can say financial, factors, social, a number of them. You can decide to describe the factors. Economic, which is the same as social, political, cultural, religious, environmental, educational, sexual, income, but again, technology. What other factors? Legal. Then safety. Something. I'm just giving something. It doesn't mean that it's exactly what I have. And then when you come to data view, so you see that these things will appear on top of it. But when it comes to the feeding, you have to feed this section. Okay. So when it comes to feeding, you can decide to feed this. Is that okay? Yeah, so you can decide to feed this. So as you can see, I have put, how many do you have? 66, right? So 66, 22, 22, 22. I want to have, it doesn't mean that they should be exactly the same, but I just want them to be the same for the sake of our analysis. And remember, the 2 is for private sector. 2 for private sector, 44. Or 22, 22, 44. And then 3. This is just an example I'm giving. I'm not saying that you can also change the data view and write them. Okay, you can change, make it string. When you make it string, now you can write it. Like you can write the actual name, the private sector, public sector, and all that. You can decide to do that. Is that okay? Yeah, so I mean, it depends on you. Any of them is acceptable. Good. Now I have my data set. So now it's the time for me to do the analysis. Okay, so let's go back to the paper that we are using. So I've entered the data. Okay, based on the responses that I got, I've entered the data. So this is just an example. Before I move on to the paper, there are a number of videos online which I think can help you. So if you want to get more about how to do the data entry and cleaning and all that, the concepts, research and management concepts training by Dr. Atif Balel video. Dr. Atif Balel has 194 videos. So those of you who want to get more idea about how to do SPSS data, what is a survey questionnaire, and so forth, I recommend these videos to you for you to watch them. Because with respect to my video, for the sake of time, I cannot do everything with you. So if you want to get more info, I recommend this video to you. I also recommend, for the sake of other analysis that we'll conduct, I will recommend Dr. Todd Grande. Dr. Todd Grande videos also to you. Dr. Todd Grande also has so many videos. Yeah, 2,900 video. Wow. Yeah, Dr. Todd has a lot of videos, and some of his videos go beyond normal statistics. So you can watch them. Yeah, but I mean, focus more on the statistical videos. Some of the things that are more of psychology and all that, but focus more on statistical videos. So get Dr. Grande's videos. And then I also recommend Mike Crowson. He also has about 394 videos on also statistics. Mike also has very fantastic videos. Then I also know this guy who I've also watched most of his videos. Oh, sorry. Yeah, Statistics and Theory from Vahid Ayadost. He also has about 159 videos. So please, if you want to get more idea, we are in an era of videos. Yeah, I always tell people in the time where the face-to-face classes, a time will come where it will even be difficult for people to do face-to-face classes, and COVID proved that to us. So you must be somebody who loves to consume videos, which will help you. Okay, so let me go back to the paper that we are using so that we can continue. So now we have our data set. So what do we do first? The first thing that we have to do is we have to conduct what we call reliability analysis, or we have to do reliability tests. And with a reliability test, we want to use a Chrombat alpha. And the reason why we are doing this is that we want to determine the internal consistency of the data set that we are using, internal consistency of the responses, which will in one way or the other also prove the validity of the data set. So what is the meaning? So I want to explain to you what is the meaning of internal consistency. Let's all look at it together. So internal consistency will define the consistency of the result delivered in the test, ensuring that the various items measuring the different constructs deliver consistent results. Okay, they deliver consistent results. They deliver consistent results. Okay, yeah, with the instrument, various aspects of the same characteristics. In other words, they have the same characteristics, they are producing the same results, and it's not like there's not too much variability differences in the results that we are seeing. Okay, yeah, validity of similar items on the test. Okay, yeah, so the similar items on the test. Good. So how do you conduct that? So let me come back to my data set and conduct this with you. So with this, you go to Analyze in SPSS. You scroll down to what we call Scale. Come down to Scale. And then the scale, you see Reliability Analysis. Click on that. So when you click on that, oh, okay, good. So even here that I'm getting, I didn't want this, but anyway, that's fine. Yeah, that's why normally I don't bring in the description of the label of the variables, because some of them may be long and then it's look some way. That's fine. Okay, so I want to test the reliability of this data set I have, which is from CSV1 to CSV1, because success factors of variables 1 to 12. So I highlight on them, I click on this, I come to test statistic, and then in the descriptives, you have to check out item, scale item if item deleted. And then you can add correlation. Then click continue. And then when you come down here, you click OK. So when you click OK to give you the results. So as you can see, the Chrombat alpha is 0.901, which is very high. So the question that somebody will ask is, what is the acceptable Chrombat alpha? What is the acceptable Chrombat alpha? So let's look at it. And you can get these things online. Okay, so let's look at it. So a Chrombat alpha of, I don't like this one. I think I prefer this. Even this, I don't like this. Yeah, there's some of them, they are all good, but I just want one which is very common that a lot of people use. And last time, remember, I showed you one. Yeah, so, okay, let me use this, but they are almost the same, similar. So if your Chrome batch alpha is 0.7 and above, is acceptable. If it is 0.8 and above, that's good. 0.9, excellent. Yeah. So, and then if it is below 0.7, then there is a question mark on your data set in terms of its reliability. 0.5 is poor. Anything less than 0.5 is unacceptable. Okay, so that's it. So that means in terms of reliability, it's very good. But as situations where you run this, you will not get 0.7 or 0.8 or 0.9. And you see that it's maybe somewhere 0.6 or 0.5. So what do you do? So in that case, what you have to do is that you can scroll down, come to item total statistics. And here you can see that normally you see some of the items will be standing out. So here you can see that they are all Chrome alpha, if item deleted. They are almost in the same range, around 0.8, 0.9. So there's we don't have any of them that is standing out, which is like kind of extreme. But if we were to be a situation where we have any of them standing out to be extreme, we'll just take it. We'll just take it out. And when we take it out and we run it again, it's possible the Chrome batch alpha will go up. Okay, so you can do this. You can try and try and try and try until you get the Chrome batch alpha to be around 0.7. 0.6 is good, but the possibility that you'll be questioning is very high. Yeah, so we are done with that. So our data is reliable, is good. The next thing to do per the paper is that we need to conduct what we call a mean scoring. And the aim of the mean scoring is to get the critical variables. In other words, we are trying to cut some of the variables out. This is important when you are dealing with a large set of variables. So here, I think he was dealing with, let me go back, a lot. I think this would be like around 20 something. So with this, you want to take some of them out before you even go into the actual factor analysis. So you can decide to use the mean scoring to determine what we call the criticality. In other words, the critical. The critical word here means, when you put it in a simple term, the most important. And some of them you can say they are not important. So to determine that you can use the mean scoring, others use what we call the normalization method. If you look at Dr. Roberts' paper, I think he used the normalization method, if I'm not wrong. Not only this paper, but other papers that he has written, he used the normalization method. So you can check out some of the other papers that Dr. Robert has written. Okay, so good, that's good, that's great. Let's keep going. Oh, good, yeah, okay. So criticality. So he wanted to determine the criticality. So he used this and then he determined the criticality, and the results he just put them in the table 3. I'll come there. But the question is, what is criticality and what is the threshold for determining criticality? So this was also mentioned in the last video. I mentioned that if you are using a 5-point Likert scale, it is possible that you set your criticality beyond 2.5, or you set it 2.5 and above. Others can also decide to set DS 3.0 and above, up to 5. Others can also set it 4. Okay, but if you are using 7-point Likert scale, it's also it's acceptable that you use 3.5 and above, 4, 5, 6. Yeah. So how do you determine this? Very simple. So to determine this, just look for a previous study, a similar study in your area, and then just find out the kind of criticality threshold that is set. Another thing too that can also help you to do this is that you can also run the data set to determine. It's all about this mean squaring is just about the mean. This is also a formula. You can also use this formula, acceptable. Others also can also use other formulas to determine it, but it's just trying to find the average, the mean of the data set. So just look at what people have done in the area, and then if it is possible, just pick something that is acceptable and then use it and move on. Yeah, or you can also come up with your own based on the data analysis, the results that you will get. So any of them is acceptable. Okay, so now we have that. So what the next thing is to do the factor analysis. So with respect to the factor analysis, once again, that is where here there's a little bit of this thing, because I've also seen studies where this pre-testing of data sets is combined with the factor analysis. Any of them is acceptable. So here, once again, with the factor analysis, now we are going into the actual factor analysis. With the factor analysis, we need to take some analysis before we do the actual factor analysis and get the principal components. So one of them is, once again, is the reliability test, which we have already done with the Krumbach alpha being 0.9 and above, which is very good. And once that one is done, the next thing to do is to conduct what we call the normality test of the data set. Normality. This is very important. In fact, this test is extremely important, the normality test. The reason why it is important is that based on the normality test results, it will influence you to choose a statistical test which will help you to analyze your data. In other words, whether your data set is normally distributed or not has a way of influencing you to choose a data set. It has a way of influencing you to choose a data set. So it has a way of influencing you to choose your data set. Okay, so let's keep going. So how do you run the normality? So there are a number of ways of going about running your normality test, but there are two tests which are very common and very popular in running your normality test. One of them is called Shapiro-Wilk test. So please read about it. And then we also have Kolmogorov-Smirnov. Kolmogorov-Smirnov. Okay. So which one is appropriate? It depends on what you are dealing with. So for example, with this study or this paper issued, they are saying that the Shapiro-Wilk test is more appropriate method for small sample size, less than 50 samples. Although it can also be handled on larger, it depends. While Kolmogorov-Smirnov is normally used for a data set of more than 50. So any of them can be used, but just the little difference is that normally the Shapiro-Wilk test is appropriate for data sets which is less than 50 respondents. And then the ones with more than 50 or more, you can use the Kolmogorov-Smirnov. Okay, so the good news is that SPSS has these two tests within the SPSS software. So we can easily get this. So how do we run this? So to run this is very simple. All that you have to do is that you can click on Analyze. So we are trying to get the normality. Okay. Okay, so let me do some kind of reality check. So far we have done this. We have done this. I've explained this to you. That's kind of sound. So now we are on the normality test. The normality test, you can use the Shapiro-Wilk test, or you can use what we call Kolmogorov-Smirnov, which we normally call the PS test. Okay, so how do you run this? Very simple. So let's go to SPSS. So when you go to SPSS, you can come to descriptives. I mean, scroll down to descriptives, then you click on Explore. So when you click on Explore, it will ask you of the kind of dependent variables and the independent variables that you want to run. Okay, the data set. It depends. You can decide to put this one here. You can put any of them in there. It's acceptable, depending on what you want to make it as dependent variables. Okay, so let's assume this is. I just want to run some of them because, but we can run all of them. Any of them is acceptable. So this is that. Then it will ask you of the statistics. So descriptives, outliers, because you want to determine whether there are extreme values in there. Then with this, you select histogram if it has not been selected. Then you also, so here you select normality plot with tests. Okay. Then you can also options, leave it like this. And then you click on OK. So when you click on OK, as I said, you can use any of them as it's running. Good. I just wanted to run some of them instead of all of them. What are we seeing here? Are they normally distributed or not? Okay. So according to the Shapiro-Wilk text, okay, it has run all of them. We use all of them as independent variables. Any of them, I mean, or we can also run them according to the sectors. Okay, so this one I decided to run them individually. That's why I made all of them independent variables. But I can also decide to run them based on the sectors: private, public, and then the academia. When I finish this, I'll go and run it for you to see it. So when you look at the test results, what is it showing? It's showing that they are all having a significant value less than 0.01. Okay, let me say this. Before you run any test as far as some of these statistical tests is concerned, you need to set your hypothesis. Okay, so the hypothesis being set here is that the null hypothesis is that we assume that the data is normally distributed. And then the alternative hypothesis is that we assume that the data is not normally distributed. Okay. Okay. So how do you set hypothesis? Okay. So you can go online. I mean, how do you state? You can learn this. Okay. This is yeah. So please read about this. So this is how this is the sign. But read more about null hypothesis and alternative hypothesis. Okay. Okay. So if you have a p-value, significant value, normally we set the threshold at 5%, but it depends on the kind of test and then the kind of significance level that you want to look at. Some of them are 1%, some of them are 10%, some of them are 5%, but 5% is normally the significance level with a 95% confidence interval. So that's the one that normally is the standard in statistics, but you can also look at others. Okay, so if your p-value is less than 0.05, what do you do? Okay, so what you have to do is that you have to reject the null hypothesis. And if you remember, I said we set the null hypothesis to say that the data set or our data set is normally distributed. It's normally distributed. And the alternative is that it's not normally distributed. So if the test statistics or the test run or the work that we did is showing that the Shapiro-Wilk test for all the variables are showing less than not even 5%, less than even, it's not even up to 1%, less than 1%, less than 1%. That means we have to reject the null hypothesis that our data set is not, we have to reject the null hypothesis that our data set is normally distributed. And if we reject that, then the alternative is saying that our data set is not normally distributed. The same thing also applies to, you can see we are getting the same results for the KS results. Okay, so here we can conclude that the data set that we are using is not normally distributed. Okay, let me go back to what I was saying. If I want to run it based on the sectors, then I will make the dependent variable to be the sectors, and then the factors, the factor list will be the individual, the factors here will be like independent variables, the individual variables. So the same thing has been done. I just click OK. And this time around, I'll get the results in terms of the sectors. They will not come in the form of individuals. So let's look at it from the sector point of view. The academia point of view, the results out. Okay, now here. Now we have the results. What's the results saying? So in terms of the sectors, yeah, in terms of the 3 sectors, this is the results that we are getting. So it is showing that if you are looking at it from the sectors point of view, it's showing that, okay, this is safety. No, I want all of them. Just give me a minute. Okay, so this is the sectors. Case processing descriptives. Okay. Well, here it has decided to show one by one. Yeah, okay, so this is the right one, the histogram. But I want it in the form of the table. Where all this is. Anyway, it decided to show it variables by variables. But the variables by variables, you look at it from the sector's point of view. So that's why you can see the three results. So if you are looking at it from financial, if you are taking the factor financial, the variable financial, the 3 sectors are saying that for the first sector, all of them are still insignificant because they are all less than 0.05. Yeah. And the same thing applies to, yeah. So this is like the individual one, but individual from the point of sectors. While the first one that we ran, they didn't come in the form of sectors. They came as just individual variables. Okay. But we are all trying to say that the data set that we have, yeah, it happens to be like only what safety. Safety is what I'm seeing, that when you are looking at this from the sector point of view, it seems that the data set is normally distributed for the first sector. The first sector in this context is the first sector as the public sector. Yeah. So the results is just saying that, like, generically or in general context, our results is saying that our data set is not normally distributed. But normally, if you are looking at it from this normal Q plot of sectors, another thing that can help you to do this is that you will see that they all line up. I'm surprised I'm not getting all of them at a go. They're supposed to all come together. Okay, they all line up they all be on this line or something here. But here we are not getting that. So now we have that, and we can conclude that our data set is not normally distributed from the Shapiro work test and the Keyes test. Okay, so if your data set is not distributed, then what statistical test do you use to test the data? Okay, so that will lead us to what we call Kruskal-Wallis test and Mann-Whitney U test. Okay, and because we have established that our data set is not normally distributed, we have to use what we call the non-parametric test to test our data, statistical test to test our data. Okay, before we go into that, I just want to help you to understand the differences between parametric and non-parametric tests. Yeah, and when we use that. Okay, good. So when you check, you see that. So anytime your data set is normally distributed, when your data set is normally distributed, then you can decide to use these things. Normally, if your data set is normally distributed, if in case we ran this data set and we saw that the data set is normally distributed, then you can decide to use the parametric test. Okay, with parametric test, you can run a one sample t-test, student test, two sample t-test, one way ANOVA and co. But because our data set is not normally distributed, then we have to find the alternatives or the opposite. We have to find the opposite of the parametric test. Okay, so if we want to run a two sample t-test where we want to compare the independent views of, let's say, two sectors, then we have to go for, instead of going for two sample t-tests and the parametric, then we will go for what we call Mann-Whitney U test. So in a nutshell, the Mann-Whitney U test is just the opposite of the two sample test under the parametric test. And what about Kruskal-Wallis? Kruskal-Wallis is also opposite of one-way ANOVA, which one-way ANOVA we use to compare two or more independent samples, independent views, independent differences among the data sets. So Kruskal-Wallis, and so forth and so forth. Okay, so once again, please, before you go ahead with these tests, make sure you determine the kind of data that you are dealing with, because that will influence the kind of test that you do after you have conducted your normality test. This is just a further explanation or something to help you out to understand the parametric and non-parametric. So read more about that. Read more about parametric and non-parametric and what tests that we conduct. Because if you don't get some of these things, well, you may conduct your work, write a paper, and use some statistical tools, which some reviewers they will attack you and may throw your paper away. Okay, so now we know the differences. So now we are clear. We can go ahead and use a non-parametric test because we have established that our data set is not normally distributed based on our normality test. Okay, so what we are going to do is, once again, it depends on what we want to do. In Wooney's paper, he conducted both Kruskal-Wallis. Okay, he only conducted even Kruskal-Wallis because he wanted to establish the differences among the respondents, because here the different respondents. So let's see the respondents. Did he talk about the respondent? Okay, he was a little bit silent. Okay, let's look at it from the point of even where they are coming from. So they are coming from different regions. Okay, so he wanted to compare that. And comparing more than two, you have to use a Kruskal-Wallis test. Okay, so the Kruskal-Wallis test is what we are going to, but in the situation where you are comparing two, once again, we're like, you want to compare two independent samples, then I'll encourage you, if it is a non-parametric data set, then I'll encourage you to go for the man-Utingy test. So I'm going to run the two for you briefly so that we can go ahead, because we don't really need them, but at least you need to understand them. Okay, so let me start with a situation where you want to run just the two of them. So what and what do you run? So if you want to run the two, you want to compare two sectors. You go to analyze, you come down to what we call non-parametric tests, and you click on legacy dialogues. And then you click on two independent samples. Okay, good. So here, I want to test all these variables. Okay, and then the grouping sector. So the grouping we have to define. So which are we going to compare? So if maybe in case we want to compare the private sector and the public sector. So let me go back again. I'm sorry to cancel this, but I have to go back again and show you something. If you remember, we said the private sector is 1, public sector is 2, and academia is 3. Oh, okay. And then it means I've been making I've been exchanging them, but that's fine. That's okay. We can move on. It's not a big deal. So what you have to do now is that here you click on analyze. You come down to non-parametric test. Then you click on legacy dialogues. Then two independent samples. Click on that. You select all the variables. Then with respect to the sectors, I've already done that. You need to set which, okay, here we want to compare the private sector and the public sector. So the private sector is 1 and the public sector is 2. If it were to be the case that we want to compare, let's say the private sector and the academia, it would be 1 and 3. So you have to define the group. Then you click OK. We want to run man-Utingy test. All the other tests, they are important, but I mean, you can watch the videos and learn more. But here our focus is to run a man-Utingy test. So you come here, options, you click on descriptives, and if you want to bring the quantile, the quartiles, that's also okay. You can decide to, then you leave this one. Okay, then you click OK. So let's see how it will run. Okay, good. So when you look at a man-Utingy test, what is the test telling us? Okay, so let's look at the asymptotic significance of the two-tail. Okay, so here too, once again, as I mentioned, anywhere you see the significance level and the significance of the test and test statistics and all that, always there is a hypothesis involved. So you need to set your hypothesis. So what's the hypothesis have you set? Or what's the hypothesis are you setting now? So here, my hypothesis is that the null hypothesis is saying that the two groups are equal. They are the same. In other words, there are no differences between the two groups with respect to these factors. Then my alternative hypothesis is saying that the two groups are not the same. In other words, they have differences. Okay, so let's look at the results for the asymptotic significance. So you can see that some of them are, almost all of them, there's none, 0.05. There's none of them which is less than 0.05. Therefore, here we will fail to reject. We won't reject the null hypothesis, because when the p-value is less than 0.05, we reject the null hypothesis. So here we will fail to reject the null hypothesis. So if we fail to reject the null hypothesis, that means we are accepting the null hypothesis. And the null hypothesis is saying that the two groups are equal. In other words, with respect to the public sector and the private sector, as far as this analysis is concerned, there are no significant differences between all these factors. They almost think the same. They don't have much differences in them. I hope you get it. So that's how you conclude. Okay, so we can run the other ones on and on and on. For the sake of time, once again, please, I can't do all. So you can also look at the other ones, okay? Okay, let me try and do the private sector and the academia. I just want to see something. I just want to see how it will go. Okay, the private sector and academia, what is happening? Here to the same. Yes, none of them is less than 0.05. Therefore, we fail to reject the null hypothesis. Okay, so I'm done with the this is Mann-Whitney U-test for comparing two independent samples under the non-parametric test. Now let's look at the situation where you are comparing more than two or more than two. Mostly, yeah. We can use the Kruskal-Wallis. So where do we get that? So the Kruskal-Wallis, you click on Analyze, you come down to non-parametric test, you click on the legacy dialogues, then you click on K independent samples. The reason why is K independent samples is that here, like the samples, the independent samples are not defined. It can be two or more. It can be, you are comparing about 15 groups, 20 groups, 10 groups, 5 groups, 6 groups, so that's why. Okay, so you just select the variables and then you put them here. And here too, you can specify the groups. So here you can say the minimum is 1 here. So here we see the minimum and maximum. And then the maximum is 3. Okay, so I think the other options have been selected. You click OK. And if you notice, let me take you back again. If you notice, the Kruskal-Wallis has already been ticked. So that's why I didn't take. So take note. What's the results? So let's look at the results here. So here too, once again, please, you need to set your hypothesis. So the hypothesis that you can set is that for the null hypothesis, you are saying that there are no significant differences in the opinion, the views, the expressions, or whatever you want to put it, of the various groups. So like, there's no difference between the public sector, private sector, whatever sector, or whatever. There are no differences. And then the alternative hypothesis is that, I mean, there are differences. Okay, so let's look at them. So with financial factor, we can see clearly that we have to reject the null hypothesis and establish that, yes, there are differences among the sector with respect to their views on the financial factors influencing sustainability in the construction industry. But when you look at all the other factors, asymptotic significance, are showing that they are more than 0.05. Therefore, we will fail to reject the null hypothesis. And therefore, we'll keep the null hypothesis by saying that there are no significant differences between them. Yeah, because almost all of them 0.9, 0.59, 0.51, 0.1. Yeah, so we are done with the Kruskal-Wallis. Please, if this one was to be a parametric data set, don't forget, we should have run the ANOVA or something. Okay, so don't forget that. Yeah, if these tests were to be where is it? I just want to show you. If these tests were to be parametric, we should have run either independent t-test or pair t-test or one-way ANOVA or repeated measured ANOVA and all that. And then when we come to correlation I'll show you the correlation. But normally correlation related to some of these tests are more, if it is parametric, it's Spearman correlation. And if it is, if it's non-parametric, if it's parametric, it's Pearson. If non-parametric, it's Spearman. Yeah. Okay, so we have these things. What next? Now let's run the factor analysis because time is running so that we can get these things over and go. Okay, so now let's run the factor analysis. So going straight. So we have everything done now. We have tested all these things. Now we can run factor analysis. I go to analyze, or you have to go to analyze. You come to dimension reduction. Dimension reduction. Then you click on factor. Then the factor, already have selected the factors. So all the factors, if you have not done that, yeah, you don't need to, unless you want to, which I have not seen it before. I want to group the data into now something that even myself I wanted to do it some time ago, but it didn't work. Like if you want to run the factor analysis under the academia under this, let's run everything together. So this, come to descriptives, you click on, you can decide to bring the univariate description, initial solution, whatever. But check out coefficient, significance level, determinant, KMO, and Bartlett test of sphericity. Inverse, reproduced, anti-image. Normally, they are not normally done, but read more about them and get to know where they are used. But these are the ones which are very common as far as most of the studies that I know are concerned. You click on this extraction, you click on we have to use the script plot, and then the eigenvalue should be greater than 1. Okay, a fixed number of factors. Unless you want to maybe change the eigenvalue, you can raise it more than 1, but not below 1, what I know. Maximum iteration from 25, that's fine. Rotation, good. So this is where we come to. So rotation, there are 2 forms of factor rotation or factor analysis rotations. So we have what we call orthogonal or octagonal rotations, and then we have the oblique form of rotation. Okay, so what is the difference? So let's go and read about it. Let's read about that. I want you to understand that. So oblique rotation and octagonal rotation are the 2 main methods that are used in factor analysis to determine the structure of a set of variables. The octagonal rotation, also known as Varimax, and it's an example, it's not always also called. An example of Varimax rotation is a method that seeks to produce factors that are uncorrelated. So here we assume that the factors are not correlated. Correlated means to be correlated with someone means like to have a relationship, you know, and to have a relationship with somebody means we all know how relationships work. I mean, normal relationships as human beings. The relationship can be very strong, can be very weak, can be normal, it can be on and off. It's like it's there, it's not there, kind of, you know. And I think you guys have done correlation before, so I mean, I don't need to really do too much on this. So here we assume that the factors are uncorrelated with each other, meaning that the factors are independent from each other. Is that okay? So that is what the octagonal rotation assumes. And an example of an octagonal rotation, or a method that we can use to check the octagonal rotation, an example is what we call the varimax. Okay, this is done by maximizing the variance of the factor loading within each factor. Then we also have another one. So the opposite of octagonal rotation is what we call oblique rotation. What is oblique rotation? Oblique rotation, on the other hand, allows for factors to be correlated with one another. Whilst the other one assumes that the factors are uncorrelated, this one assumes that the factors, the oblique, assumes that the factors are correlated, meaning that the factors are not independent from each other. This is done by maximizing the similarity of the factors within the original variables. Oblique rotation can be done using various methods, such as, so examples or methods that we use to run the oblique rotation include, so you see Promax, direct oblivion. In summary, the octagonal rotation produces factors that are independent from each other, while oblique rotation produces factors that are correlated with one another. The choice between the two methods depends on the research question and the assumptions of the analysis. So here, it depends on you, it depends on your assumptions, it depends on so many things. So here, you can decide to choose. So if I am choosing, or which I'm going to do now, I'm going to choose based on what I've read, based on the studies I've done, based on what I know from the previous studies in our field. Is that okay? Good. Even there are differences between the, so you see ChatGPT is writing for me. Wow. The work of AI. Even there are differences between Promax and the Promax and then the direct oblivion. Okay, so the Promax and direct oblivion are two commonly used oblique rotations. Promax is a type of oblique rotation that seeks to produce simple structure, whilst, so I just want you to understand, okay? I just want to give you an explanation so that immediately I run the thing, we finish it, because understanding is very important. It's not just about this. Yeah, so it's that seeks to produce simple structure where each variable has a high loading on one factor and low loadings on the other factors. Promax rotation is computationally efficient and is often used when the correlation between factors is expected to be moderate or high. Promax rotation assumes that the correlation between factors is constant across all factors, and therefore it adjusts the factor loading to maximize simple structure. Oblivion is another type of oblique rotation that allows for correlated factors, but does not assume that the correlation is constant across all factors. Okay, so please read about these things, read about them. Read about them. Okay, thank you so much. Now let's come back to what we are doing. So I'll choose, so other examples of octagonal rotation methods, apart from varimax, are quatermax, and then equimax. So these are other methods which are used. And then the two, which is direct oblivion and Promax, are more of oblique rotation. Okay, so I'm going to use varimax because varimax is well used, well known in our field. So find out more why we use varimax. What is the essence? What is the importance? Read more about that. Okay. Then options. Here I will not suppress anything. I'm just going to leave everything. But there are situations where you can decide to suppress the factors that you want to extract. In other words, a variable can can join a group or a factor if the variable has maybe a factor of more than, let's say, 0.4 or 0.5 or 0. Something. And this factor suppression is one way or the other is influenced by the principal component. Yeah, you see a method. If you are using GLS or maximum likelihood principal, what? So here we are using principal component, the method of factor extraction. Okay, principal component means like we want to get the principal groups that these factors will belong to. Okay, so we have these things, and I've put them there. Now I will click OK to see the outcome. So let's see. So the outcome is showing me that. Let me start from the top and start the explanation so that you get it. Okay, so now we have the normal descriptives, we have the mean, we have the standard deviation, and we have the total number of responses that we work with. So in this context, here the mean score is showing that none of the factors should be taken out because we're having factors which are having means more than even 4, which is very high. Standard deviation is okay, and then all that. Like, let's come to correlation. Are they correlated? The significance level are showing that, yeah, they are all okay, except few of them. I think, yeah, and even, are they even significant? Yeah, okay, they are not even, I mean, they are not bad. Yeah, because none of them is more than 0.05, 0.05, 0.05. Are we having any of them? So the correlation significance, that means that's fine. Yeah, okay. Yeah. So yeah, the correlation matrix is cool. I'll move on. Don't have any of them. KMO. Now let's come to the KMO. So we have the KMO, measure of sampling adequacy. So we have it to be 0.865. So now let's determine the acceptable KMO. Okay. Acceptable KMO for factor analysis. Okay, so KMO values vary from 0 to 1. The KMO value between 0.1 indicate that sample is adequate. So this is just 1. It's possible we also look at other papers and they will say something a little bit different. Okay, yeah. So you can see that here 0.7 to 0.8 is average. Anything 0.6, 0.5 to 0.6 is considered to be mediocre. 0. Less than 0.5 is terrible. Around 0.5, yeah, and below is terrible and not acceptable. And then around this is okay. So you have to choose the one which is better. But I think from the results I got, we got 0.8, which I think we are good to go. It's great. It's nice. Very well. So the KMO, the sampling adequacy has been satisfied. Now let's look at Bartlett sphericity. This Bartlett sphericity is showing that it's significant. And what is it? What is it for? So you need to understand all these things. Yeah, what is it for? Yeah, why? What was their sense? The test whether so let's look at why Bartlett sphericity. Let's look at why. Provide information on whether the correlation in the data are strong enough to use a dimension reduction technique, such as principal component analysis or factor analysis. So this is extremely important. If you run this test and you don't get a significance level, then it means you can't go ahead and even run a principal component analysis or do any factor extraction. Yeah, so that test was also established to say that our data set is good enough for us to do that. Now let's come to commonalities. So what is commonalities? We need to find out why commonalities. So we need to know the purpose of commonalities is the amount of variance in each variable that's accounted for. So the variance is up to 1, okay? So if a variable is inching or is getting closer to 1, then it's good. If your commonality of each of the factor is getting closer to 0, then it's not good enough. So you may consider taking it out. So if I am looking at this, anyone which is less than 0.5, I will take it out. But other factors must also be looked at. Yeah, so read about that, because here they are good. They are good. Some of them are also 0.4. Which indicate that we need to do something a little bit about our data. Let's go back and check something. Now let's come to the total variance explained. And that's where we see the eigenvalues and all that. What is eigenvalues and what is it for? Okay, so here too, we need to know what the eigenvalues is. Okay. Do we determine the threshold of the commonalities? As I said, 0.5 and above. Okay, but other studies also, as you can see from here, I think other settings are 0.4, other settings are 0.3, depending on, but most of the studies that I've seen, even can see between 0.25 and yeah. So it all depends on the paper. So always get a paper to support your threshold. Very important. Now let's come to the eigenvalues. Why eigenvalues? Yeah. So why eigenvalues important in SPSS? So are they important? Eigenvalues represent the total amount of variance that can be explained by a given principal component. They can be positive or negative in theory, but in practice, they explain variance which is always positive. If eigenvalues are greater than 0, then it's a good sign. Okay, so it's above 0.1 is good. That's a variation difference in terms of this is a little bit of regression and all that. I don't want to take you there, but I remember when I was doing my master's and undergrad, we used to I used to do a lot of statistics, and we used to do a lot of regression and all that. And we used to look at the R square, the adjusted R square, and all that. It has something to do with this, but for the sake of the work that we are doing, I don't want to veer into that. Maybe you can read more about that. Okay, so eigenvalue represent the total variance explained by each factor. Each factor. So if you put all of them together, at least it should give you all the factors that are coming together should be greater than 1, which is normally the threshold above 1. So based on this, there are 2 components. According to the component, under those circumstances, we should extract 12 components, but the 2 of them stand tall. And these 2 that stand tall, they were able to get eigenvalues more than 1. And you can see it from here, the total, the initial eigenvalues and all that. They only have the rest don't have eigenvalues. Okay, for these components, they are less than that. So they couldn't get factors to be rotated on them. Another thing too that can help you to determine the eigenvalues is to use a scree plot. So when you look at a scree plot, anything above 1 will tell you the number of components, the principal component that have been extracted from the factors that you are working with. So it's so clear from here, 1, 2, 2, and it's the same also here. With the total rotation loadings, sum of squared loadings of 58%. Not good enough, but anyway, it's good. Yeah, at least 58 is okay, but normally when it's 60, 65, 70, then it's extremely good. Now let's come to the component matrix. So this is the normal component matrix which has not been rotated as extracted, 2 component extracted by the principal component analysis. Okay, so as you can see, yeah, but very soon I'm going to explain something to you, the factor loadings, and that will be the last thing maybe last but one thing, then we are done. Okay, so, and then they rotated with a varimax. Rotation converged in 3 iterations, 2 components. And these are the variables. Okay, now let me come to where would these factors belong to? So we are going to use the rotated matrix. And then these are the component transformation matrix for the 2 component, principal component. Okay, showing that they can rotate with each other very well. The Kaiser normalization. Where would these factors belong to? So you use what we call a factor loading. So with the factor loadings, you can see that the financial factor having 0.7, and in component 2, in other words, group 2. In group 1, it is having what? 0.164. So where do you think financial factors should belong to? It should belong to the components in which you can see the higher, if they are 2, if they are more than 2, the highest factor loading. Okay, to make our work easy, normally this is what we do, and that's where I mentioned that you can suppress your results. You suppress the results by taking out the small coefficient. So here you can say that anything, as I can see, anything 0.5, I think that would be good. Yeah, but here once again it's also set by you, so you can decide. And make it 0.5. Yeah, so 0.5. So you can see that the factors have been arranged properly. So financial, social, political will go into the second group. And then cultural, religious, environmental, educational, sexual, income, technology, legal, safety, they will also go into the group 1. Okay, but the question is, what is factor loading? I mentioned factor loading. What is it? So you need to understand the factor loading. So what are no, that is not what I want. No. I just want something that will be easy for you. Okay, let me make it this way. So that it will be. The factor loadings, what is good for factor loading value? Once again, it depends on you. A good definition of factor loading is to look at is the correlation between the item and then the factor. A factor loading of more than 0.7 usually indicate a moderate consideration. So let me check an image. Factor loading threshold. Here too, please, once again, depends on you. There's no acceptable factor loading that is set. So you can look at, this is what somebody has done. But once again, it depends on how they went about it. So set your own factor loading. Okay, yeah. So according to them, if you're having a sample size of 350, your sample size is 350 and your factor loading is 0.3 is acceptable. If your sample size is 250, fine. But if you are dealing with a smaller sample size, or let's say 50 samples, then your factor loading should be higher. Okay, so you can use this thing to guide you. You can use this, and even this is for SAM. Yeah. It's for SAM. I think it can be a good guide. But read papers, read previous studies, read papers. When you read papers, you'll be able to set your factor loading threshold. But the one that I know most papers have written 0.7. 0.7. Okay, so let's assume you have these factor loadings, you have these groups, these two groups. So we have been able to extract two groups from the 12 variables. So what do they mean and what do they represent? Okay, so in terms of exploratory factor analysis, don't forget I mentioned that here we don't know where the group belongs to. So it's a software that is trying to help you to assign the variables into groups. Okay, so now the software has helped us to assign variables for the groups. So what next? So the next thing to do is that you need to give it a name. So here, this is where your creativity will be needed. So if you look at what Dr. Wuni did with his group 1, he gave it a name, adequate technical capability and infrastructure. Group 2, he was able to extract how many groups? He got 4 groups. He got 4 groups. That's fantastic. You got 4 groups. So you have to give it a name. The question is, how do you give it a name? So you give it a name based on the features of the factors in there. So here it's your own, but I mean it's your own doing. It's your own creativity. You create it. Be creative, create it. So you create it by saying that, okay, looking at the features, looking at their title, looking at their names, I think if I give a name adequate technical capability and infrastructure, that'll be fine. Maybe if I am the one who is looking at this, I'll give it a different name. Okay. Yeah, so it's up to you at this point. So these two components, I can decide to give it a name like socioeconomic. Now the second group, I would say their name is socioeconomic factors. While the last group, I can give it a name environmental factors. Something. It's just an example. I'm not saying I'm right. That's an example. Yeah, so okay, so if you do that, what next? The next thing is to just, when you are writing about it, you have to interpret. So this is a continuation of a paper that we are developing, but I'll go ahead and show you something that he did so that you can get this. So if you can see this, you can see that all the 4 factors, he has explained them. Okay, maybe he didn't do it. Okay, he did. Yeah, so you can see in the discussion session, we do more because we need to do the fuzzy synthetic aspect. But when you are done with that, you need to explain these factors and why you think they have something in common. That's why you have put them in the same group. Not that you put them in the same group, but why you think they belong in that group. You have to explain to us why you think they belong in that group. And then what are they? What are these factors? Or what do they represent? So do some kind of explanation, explain, and then help us to understand and all that. Once again, it depends on the kind of study that you are doing. So the explanation will influence that. Yes, so there's no one way to go about that. But in the course of explaining, you have to help us to know the factor loadings, the eigenvalues, and all that. You need to bring all that in. Yeah. Okay. This is a fantastic thing to do. I mean, in fact, I really enjoy this thing. I really love this. So I'm hopeful you also enjoy it. And if you have a question, you have anything, I'm available to assist you. So do take good care of yourself, and I'll come to you again with the fuzzy. Okay, so all these things have been captured. So the next video that I'm going to work on will be on fuzzy. Yeah, so the fuzzy synthetic evaluation. Yeah, so I'll come to you the next time with the fuzzy synthetic evaluation. So please do take care and enjoy yourself with these videos. I know that learning statistics sometimes they can become very intimidating, but if you tackle them little by little, I think you can get there. So take care and expect my next video. Thank you and bye-bye.